In today's video, you'll be learning about integration by parts. As you can see here, this expression is actually an integration by parts problem. Well, this one here, with the one I'm about to write, it can be, but you shouldn't have to use integration by parts. Now, you should use integration by parts when you can not simplify the expression right here, right? And basically, an integration by parts problem is when two expressions are being multiplied with each other. However, you should not use it, right, when the expressions can be multiplied with each other to form another expression, which then can be simplified using normal integration techniques. And that can be applied to this one right here, but not this expression right here. So we use the integration by parts technique in the first expression and not the second one. So the formula for integration by parts is the integral of u times dv let me write that a bit better. Yeah, u times dv is equal to u times v minus the integral of v times du. And we use something called LIOT, the acronym, to find what u will be equal to. And I'll get to in a minute what u exactly is. Yeah, in a minute I'll show you what u exactly is. Okay, so L stands for logs, I stands for inverse trig, A stands for algebraic, T stands for trig, E stands for exponential. Okay, so to identify what u will be in the expression, right? You should look in the expression. U will either be one of the products that are being multiplied with each other. So it will be either x or ex. Now, right? Since x is algebraic and ex is exponential, and since algebraic comes before exponential, u will be x. So it's whatever expression is precedent with the other. Okay? So then we take the derivative of both sides of dx, and then for dv, we make dv equal to e to the x power times dx. And then v is then equal to e to the x power. And then when we follow the formula, u times v, we don't have to write the left-hand side. It's not really that important. U times v, so x times e to the x power, minus the integral of v, so e to the x, times du, so just dx. Okay, and then we get an answer of x times e to the x minus e to the x plus c. That's our answer. Alright. Now I'll give you a few integration by parts problems that you can do by yourself. Alright, so here are the problems, and pause the video and see if you can do them by yourself. Alright, now that you've given an attempt, I'll now solve them. So I'm going to delete the bottom two for more space. So, right, before we going to solve this, let's first write our acronym out. And again, for L stands for logarithm. And automatically, we see that we have a logarithm here, ln x. So as a result, u is equal to ln x. And since x is algebraic, we know that logarithm precedes algebraic, so that's why u is equal to ln x. We take the derivative of both sides, we get 1 over x. dv, as a result, is equal to x times dx, and v is then equal to 1/2 times x squared. since that's the integral of x. Okay, and then u times v minus the integral of v times du. That's our formula. So now let's match that. So u times v, well, that's equal to 1/2 times ln x. Alright, let me write it a bit better for you guys. More orderly. Yeah, so 1/2 times x squared times ln x. Okay, minus v. What is v? V is just 1/2 times x squared times, what is du? Du is just, I forgot to put the dx here, my bad. Du is just equal to 1 over x times dx. Okay, so then we write this whole thing out, and we get minus 1/2 x, 1/2. We can pull out the 1/2 from the integral times x dx. So then our answer would just be, right? Okay, so then yeah, our answer would just be, I read it like, yeah, somewhere here. Actually, hold on. I'll just solve the integral first and then write it out. Okay, so to solve the minus 1/2 times integral of x dx, I'll rewrite it here. So the integral of x is just 1/2 squared. So times 1/2 squared, meaning equal to negative 1/4 times x squared. Okay, that means our answer is just 1/2 times x squared times ln x minus 1/4 times x squared plus c, and that's your answer. Okay. And now for the second problem, I'll solve that now. So for the second problem, which was integral of tangent inverse x times dx. So before I was saying that there's going to be two expressions there that will be multiplied with each other, and that is still true. However, here it's implied that they're times with each other. You just the thing is, right, that sometimes you're just gonna have to say that it's times one, right? If you only have one expression sometimes, and this is only sometimes, you're gonna have to say, well, that expression is gonna be times by 1. Okay, so we can rewrite this as tangent inverse x as times 1. Okay, and I'll get to you why. So as you can see here, Liot. Okay, so inverse trig, and right, we have to use inverse trig, and we just make u tangent inverse, since 1 is technically algebraic. Use tangent inverse, and then du is just, we just then be equal to 1 over x, 1 over 1 plus x squared. I'll put this in parentheses. Okay, and then dv, and this is why we put 1 there, is equal to dx, 1 times dx. Okay, so whenever you have like a inverse trig or something, you should probably use integration by parts and then put times 1 just to indicate that the 1 will be the dv. Okay, so then dv, that simplifies to v is equal to x, and then v times u, x times tangent inverse x minus x, or v, times du. Keep forgetting to put the dx there. Yeah, I keep forgetting this, but always make sure you put the dx after every dv and du. So make sure you put dx right here. Dx. Okay. Okay. So anyway, and then so integral of x times du. So then 1 plus x squared, and then dx. Okay. Now let me rewrite this here. Okay. So okay, and then so in order to solve this one, right, we actually have to use u substitution. So when we use substitution, right, let's just make 1 plus x squared. And hopefully this integration here, problem here, seems familiar because it's not too bad, as you can use substitution to solve it. Okay, so u is equal to 1 plus x squared. Du is then just equal to 2x. Okay, and then now we have x over u times 1 over x, okay, du. So when that is all solved, we have 1 minus 1 over u du. Now we have our answer, right? Because all we have to do is just plug in du back in and just solve for 1 over u and then plug in u back in. So the integral of 1 over u is this ln, right? So now let's just rewrite this here, meaning our answer is just minus 1/2 times ln, remember absolute value, of 1 plus x squared plus c. And that's your answer. Okay. Now let's move on to our final problem, which was the integral of x times sine of x and d of x there. So yeah, Liavat, I mean, or however you want to call it. So sine of x, right? Sine of x is actually trig, and algebraic is precedes trig, meaning u will be equal to x. Take the derivative of both sides, you get dx. I finally put dx there, didn't forget it. So, and then we put dv is equal to sine of x dx, and then v was equal to negative cosine x, and then x times negative x times cosine, since u times v, minus, remember, it's just this, and then times negative cosine x, times du, which is just dx, so you put dx here, and then, right, we can simplify this even more by saying negative cosine x plus, right, you can take out the negative 1 here. Let me just erase that because people might get confused with an equal sign. Okay, so then, so the integral of cosine dx, and now we have your answer, which is just negative x times cosine x plus sine x plus c. Alright, that's your answer. So I hope you enjoyed this video, and that was integration by parts, and I'll see you in the next video.